Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. So in this lesson, we are going to solve this question from acceleration analysis. So far in acceleration analysis, what we have covered? We have covered the analytical method and some examples of analytical method, and then we covered the graphical method and then some examples from graphical method. Even the same question we have covered in analytical method as well, because it is a gate previous year question. It has been asked in gate 2019 set 2. Okay, so same question we are going to solve, but using the graphical method. As we saw that while solving this question from analytical method, the calculation was somewhat, I will say somewhat lengthy, right? And it required some manipulations here and there. We have solved this question. I have explained this question to you at that time. But let us see how this question works with graphical method, whether it gets even more complex or it is very easy and simple to solve. Let us start and see. The question says that the crank of a slider crank mechanism rotates counterclockwise with a constant angular velocity omega as shown. So we have a slider crank mechanism in the question. As you can clearly see here, this is the crank which is rotating. This is a slider which is sliding, right or not? So the crank of this slider crank mechanism means this part rotates counterclockwise, which you can see from the diagram, the direction of arrow, it rotates counterclockwise with a constant angular velocity omega. Okay, you have to assume the length of the crank to be r. So this length here, the length of the crank is to be taken as r. The question says that using exact analysis, the acceleration of the slider in y direction at the instant shown when the crank is parallel to x-axis is given by what option? So options I have written here so that we get space in this place. So out of these four options, you have to tell using exact analysis the acceleration of slider in the y direction when crank is parallel to x-axis at this instant. Okay, so this is a somewhat complex English statement, right? Many things are mentioned here and there. Let us decode it one by one, because whenever you get a question, it is very important to decode the question well. If you don't understand the question, if you don't understand what you have to do exactly, how will you be able to do it? So the question says that using exact analysis. Using exact analysis means either you use the analytical method, that is the exact analysis, or graphical method with certain restrictions, with certain restrictions, that will be considered as exact analysis. Why complete graphical method is not a exact analysis, that I have told you in few of the previous examples, right? Recall the previous lesson, the previous example that I showed you, where we were having a point O, and whether point P was about to come on the right or on the left of this point was decided by the exact diagram, the exact vector acceleration diagram, which can only be drawn if you have proper scale and all the tools to measure the angles, which you won't be having in any of the examinations that you are planning to write. That is why all the questions cannot be solved exactly using the graphical method. There are only some set of questions which you can solve exactly with exact analysis using the graphical method. In rest questions, you will face problems because you cannot draw exact acceleration diagram with scale. in your exam. Now, even if the question did not mention that use exact analysis, will you use inaccurate analysis, inexact analysis? No, you will always use exact analysis. So, this is something which is in a way redundant in the question. So, analytical method we have already used to solve this question. Let us see how graphical method turns out to be, whether graphical method will be suitable for this question or not. Okay. So using exact analysis, the acceleration of the slider, this is the slider, the acceleration of the slider in the y direction, where do you decide the direction from? How can you decide? It has given you. And these are the small things where students can miss upon. Now you will think that, sir, what will happen? Even if I missed it, what will happen? I know that x is going to be horizontal, y is going to be vertical. But no, if gate wants to trick you here, it can easily trick you. It can give this direction to be x and this direction to be y. Now you will think that, sir, how is it possible? X is always horizontal, y is always vertical. But my dear students, who told you that for this particular mechanism this has to be the horizontal? How do you know? Maybe this mechanism is installed, it is installed like this. The same diagram I have drawn, this same diagram I have drawn here, I have just rotated it 90-degree anti-clockwise. So in maybe this is the actual mechanism, and the question gave you the mechanism with a different orientation, right? So it may be possible that this is x, means this is x axis and this is y axis. The gate can play trick here. That is why I want you to read the question properly, read the diagram properly, whatever values are mentioned, whatever notations are mentioned, pay attention to them. I have told this to you earlier also. There are certain question where question will slightly mention g is equal to 100 meter per second square. Within the diagram itself question will mention, and you will just overlook it, you will just not pay attention to it, you will move forward, you will solve it by using 9.81 and you will get the wrong answer, because within the range it may not lie. If you use 10 instead of 9.81, sorry, if you use 9.81 instead of 10, getting the point? That is why make the habit to read the question properly, to read the diagram properly. Every small thing, every line, every word mentioned in the diagram should be paid attention to. In this question, it is easy for you because x is given as horizontal, y is given as vertical. It is very easy. It is asking you the acceleration of the slider in the y direction. This is the y direction, means along this line you have to find out the acceleration of the slider. And it is very logical as well, because the slider can only slide along this direction. It is confined, it cannot move in this direction at all. It cannot have any component of velocity other than y axis, because it is totally constrained along the y axis. So it is very much logical that acceleration of the slider can only be in the y direction at the instant shown. At the instant shown, I have discussed this already. Almost every question of velocity analysis or acceleration analysis will mention this, because it's a moving mechanism, it's a dynamic mechanism. Every instant the orientation is changing. The crank which is here currently, it may move to this point at the next instant, at this point to the next instant. So it is continuously moving, continuously changing. Whatever question we do, whatever analysis we do, is at any given instant. So using exact analysis, the acceleration of this slider is to be told in the y direction. It can be in this direction also, in this direction also. We will see that at this instant when or where the crank is parallel to x axis. So it has given that at this instant the crank, means this crank, is parallel to this x axis. So what did we conclude from this? There is a crank, there is a slider. Crank is moving counterclockwise. The slider will also move accordingly. The crank at this point is parallel to x axis, and the slider can move parallel to y axis or along the y axis. And you have to tell how much will be the acceleration of the slider in the y direction. You can see that options given have negative as well as positive options, right? It has negative options as well, positive option as well. It means The sign also can play some importance here. It may be possible that the acceleration that you get can be in this direction, then it will be considered as minus, negative. And when it is in this direction, it will be considered as positive. Why? Because reference it has given you, this is y-axis, positive y-axis, and the direction below will be negative y-axis. So if acceleration lies in this direction, opposite to this one, then it will be negative acceleration with a minus sign. And if it lies in the same direction with respect to this axis, then it will be a positive acceleration, positive sign. So we have understood the question thoroughly, and now is the time to use your pen and start solving it. Since in the previous cases of acceleration analysis, we have solved some very complex acceleration diagrams. Those complex diagrams which have very rare chances of being asked in GATE, but they help you build your concepts of acceleration diagram. And trust me, since we have covered those cases, this question will look very easy to you. You will not even believe that how come such a easy question GATE is asking from acceleration diagram. So ideally, I want you to pause the video at this instant and now try to solve the question on your own. I'm continuing the discussion. The very first thing that we will do in this diagram is that we will name the points. No point has been named, so we have given A, B, C, three name. This center of the crank is A, this point here is B, and this point here is C. The point C lies on the link BC as well as on the slider. Point C represents the slider also, and it is one end of link BC also, right? Now, as I have told you, the very first thing to do in the question of acceleration analysis is to plot the point of zero acceleration. This point A is the point of zero acceleration. It is at rest, right? So we have plotted this, just a point, very simple. And let's denote it with small a. After plotting this point A, what do we do next? We keep on moving to the next point and then to the next point till we get our answer. So from point A, we are going to move to point B, then we are going to move to point C, and point C is going to give us the answer, right? So from A, we need to move to B. Look at this point B. How is this going to move? Since AB is the crank, B point is going to perform circular motion about A. It is going to rotate counterclockwise in circular motion about A, right or not? So it is definitely going to have a centripetal acceleration which will be having a direction towards the center like this. This is the arrow that I have shown, right? And other possible value of acceleration will be tangential acceleration perpendicular to the centripetal one. As we already know, these are the two components of acceleration for any body which is performing the circular motion. So for AB, we are going to have a centripetal acceleration component, centripetal acceleration of B with respect to A, and tangential acceleration of B with respect to A, right? Since it is rotating about A, so it is decided with respect to A. Okay, since we are sitting on A and we are looking at the motion, observing the motion. Okay, this is the I. Now let us try to plot these two accelerations on the acceleration diagram. As the question has mentioned that AB is parallel to x-axis. So obviously this vector will also be parallel to x-axis, right or not? This is the vector of acceleration, centripetal acceleration of B with respect to A, right or not? So let us plot this vector here. Okay, we have plotted this vector which is showing you the acceleration, the centripetal acceleration of B with respect to A. Now let's pause here for a second and understand and revise a few things. Can we plot a proper vector here? Do we know the magnitude of this vector also? Because if we don't know the magnitude, we can only draw a infinite line like this. We cannot put an end to the vector if we don't know the magnitude. Let us have a look at the question. What question has given us? Question has given us the length of the crank, which is r, and the angular velocity omega. Both of them will be considered as given values. You cannot think that, sir, r is not known to us or omega is value is not known to us. Why? Because look at the options. The options are given in terms of r and omega only, right? R and omega are considered as given quantities for this question. So you don't have to consider them as variables. They are values which are known to you. All right. So when you know r and omega, you can easily calculate the centripetal acceleration of B with respect to A, because it is equal to r omega square, right? We have covered that already. So r omega square is the centripetal acceleration of B with respect to A. R is considered as known, omega is considered as known. So we can definitely put the arrow on the vector. We can have a definite length of this vector. Direction, obviously, we already know. Now, ideally, what we do at this point of time, tell me, recall from the previous examples. Ideally, what we do after covering the circular acceleration, we move to tangential acceleration, which is perpendicular to the centripetal acceleration. So what we used to do in the previous examples, we used to draw a perpendicular line, and that will represent the tangential acceleration of B with respect to A. Now, obviously, you should have some details so that you can put an arrow either here or here. Maybe question will give you the value of alpha, so you will be able to decide the magnitude. Maybe the question will also give you the direction of alpha, so you can also decide the direction of A. But in this case, question has not given you any value of alpha, and direction also is not given to you. So will you ignore it? We will not ignore it. We will try to find out its value. Its value is r alpha, right? The tangential acceleration is r alpha. R is known to us. What about alpha? Read the question carefully. Question said that the crank is rotating with a constant angular velocity omega. Constant angular velocity means the rate of change of angular velocity is 0, and rate of change of angular velocity is nothing but angular acceleration. So angular acceleration is 0, and if angular acceleration is 0, then this tangential acceleration will also be 0. Hence, what we can write? We can directly write this value to be 0. It has simplified the question for us. Only one component of acceleration we have. We don't have two components of acceleration. So ideally, we used to plot the tangential part ideally in other questions. And then we used to join these two together. So resultant of centripetal and tangential component used to give us the absolute acceleration. But in this case, since tangential acceleration, this part is 0, so this point and this point will merge together, will coincide together. Since this vector does not exist, this vector is 0, so this point and this point will merge together. This used to be point B, but since these 2 points are going to merge now, so this point itself is going to become point B, because you don't have two components, only single component of acceleration you have. So this value of acceleration can also be written as net acceleration of B with respect to A. We can remove this superscript of C, which is used for centripetal, because it is the absolute value of it. Also, we can write it directly as acceleration of B. Why? Because acceleration of B with respect to A means acceleration, absolute acceleration of B, because A is at rest. So these are the three different nomenclature which can be used to represent centripetal acceleration of B with respect to A. Okay. So at this point of time, we will remove this C word here, so that it represents the acceleration, absolute total acceleration of B with respect to A, which is equal to centripetal also, because tangential part is 0. Okay, moving to the next link. We have reached point B. Now just one step is left. From point B, we need to reach at point C. Let us do that. For link BC, what do we have? What are the two values of acceleration? One is centripetal acceleration of C with respect to B, and other is tangential acceleration of C with respect to B. Right? It is very important to know that whether we are telling the acceleration of B with respect to C or acceleration of C with respect to B. I have already covered this in previous examples and in theory, so I am not going to repeat it. I am directly moving ahead with the approach that I have told you. So I have told you to draw a hinge like this, right? This is representing point B, and this link BC will be drawn here, right? So let me draw it here. Link BC will be drawn here, right? Now, as I have already told you that why we consider this as a hinge and why we consider link BC like this, from that knowledge we can understand that this acceleration is going to be the acceleration of C with respect to B and not acceleration of B with respect to C. Okay. And since C is supposed to rotate about B like this, it is the relative representation of BC, not the absolute representation. So since C is about to rotate, it is assumed to rotate like this, to move like this about B. So the acceleration, centripetal acceleration of C with respect to B is going to be in this direction, right? It will clearly be the acceleration of C with respect to B and not B with respect to C. Okay, this is the direction of that. And the tangential part of this will be drawn perpendicular to this. That also we know, this is the tangential acceleration of C with respect to B. Correct? Now let us try to plot these two values of acceleration on the acceleration diagram. Now, how do we know the value of this part, the centripetal acceleration of C with respect to B? We do it by r omega square, but here r is going to be different. This r represents the length of crank, but for BC, the value of r is this one. This is representing the value of r, which is the length of BC. So here we will be writing BC multiplied by omega BC square. Correct? The value of BC, the absolute length of BC, as of now we don't know. Don't think that root 2 is the value of BC. I will come to that why root 2 you cannot consider as the length of BC. Coming to omega of BC, let us try to find out omega of BC. And at this point of time, recall and revise the previous cases, the theory also as well as the examples also that I have told you. I have clearly told you that to know the angular velocity or maybe the velocity of any other point while doing acceleration analysis, you have to go back to velocity analysis, right? That is why velocity analysis is done first, is covered first before acceleration analysis, so that you are in a state to find out any unknown velocity or angular velocity using the velocity analysis approach. Okay, so you tell me, how will you find out the value of angular velocity? Again, if you solved this question on your own, very good. But if you didn't solve it on your own, I want you to pause the video again here. Pause the video and try to tell me the value of angular velocity of BC. I am continuing the discussion. Look, for that, let me first clear this diagram. Now, for that, focus only on link BC. What should be the angular velocity of BC? I have told you 4 different approach of velocity analysis, right? And I have also told you in which order you should start solving them, depending upon whether you want to find out linear velocity or whether you want to find out the angular velocity. Now, in this case, we have to determine the angular velocity. But this is a special case of angular velocity. How? You will see very soon. So let us use the basic concept method, which I named as Exergic basic concept method. Let us use this concept of velocity analysis at this point of time. What was the first thing that I told you in this method? That try to visualize the mechanism, how the mechanism is moving. You should be able to visualize that. As a mechanical engineer, it is very useful tool for you, the ability to visualize. So clearly, it's a very simple mechanism, honestly. AB is rotating like this, right? So point B will try to move up and point B will move up. So it will drag the rest of the link also with it. So rest of the link will also try to move up. So clearly point C will also try to move up like any general slider crank mechanism. This is essentially a slider crank mechanism, right? Only the orientation is shown different, but it is a slider crank mechanism only. So AB is rotating like this, B is moving up, C is also moving up. So this is the case that we have here. To find out the angular velocity of BC, as I have told you earlier, it will be very easy for you if you know the velocity of other two ends, right? So what will be the velocity of B? First answer that. Look at this link AB, it is rotating about A. So velocity of B is equal to R omega. R means actually R because this value is R. AB is equal to R. And this angular velocity is also omega. So VB is equal to R omega, right? Coming to point C. We don't know any such formula through which we can directly find out the velocity of C, but we can tell that it is going to be in the upward direction, right? I have explained that funda to you, how using visualization you can easily know that this point is going to move up. Now you again apply the second funda of the exergic basic concept that I have told you. That is the funda of rigid body. Again, I have told this enough number of times, so I am not going into the details of this, but you can clearly understand that since BC is a rigid body and this is the velocity of B and this is the velocity of C, it can be in any direction. But since it is a rigid body, the distance between them can neither increase nor decrease. It will remain constant, right? And it can remain constant only when the component of velocity of B and component of velocity of C along BC are equal, right? So since I have covered this already, I am not explaining and directly writing it. This angle will be alpha, this angle will also be alpha, since both of them are parallel to y axis. This is going vertical. If AB is horizontal, this velocity will be vertical because it is 90-degree. The velocity of slider also is vertical. So these two lines are parallel to each other, which are intersected, which are cut by a common line. So these two angles will be alpha each, right? And hence VB cos alpha, this is the component of VB along BC, will be equal to VC cos alpha, which is the component of VC along BC. Cos alpha will get cancelled and you will get VB is equal to VC. Interesting. This velocity of C is equal to the velocity of B. And now recall, is it the first time that you have got such a case? You have solved such problem earlier. Let me show you the exact diagram of what case we have solved earlier. You can recall this example which I taught you in one of the previous units. I think it is a simple version of that diagram. So this is the setup. This is moving counterclockwise like this. This is A, this is B, this is C. The question was, the earlier question that I am referring to, that what will be the angular velocity of BC, and four different options were given to you, I think. Since the velocity of B will be in this direction, R omega, and using this same concept, C will also be moving in this direction. So they have to be same. And if both of them are same, just focus on the link BC. If link B and C have a configuration like this, such that B is also moving in a particular direction and C is also moving in the same direction with the same magnitude, are they rotating? Or are they simply translating? In my opinion, they are simply translating, moving linearly, no rotation involved. Both the ends are moving in the same direction with the same velocity. So all other points on this link also will be moving same direction with the same velocity. So this link basically is performing translational motion and not rotational motion. So omega for such case will be 0. Recall, this is the example that we have solved earlier. Same situation we have here. VB and VC are in the same direction, and we have proved by taking the component that this velocity of C is also equal to velocity of B. So both these velocities are same. So basically this BC link is doing translational motion. Its angular velocity is 0, and since its angular velocity is 0, the centripetal acceleration will also be 0 since it is not performing circular motion. So this acceleration value here will become 0. Great. 4 different accelerations were involved. Out of those 4, 2 have already become 0. Coming to the final acceleration, tangential acceleration of C with respect to B. We know that tangential acceleration of C with respect to B should be perpendicular to centripetal acceleration. Centripetal acceleration is 0, but tangential acceleration's direction will not change by that. It will be in this direction only if it exists, right? And this will be equal to R alpha. R means this distance, BC, this distance. R alpha of BC or CB. This is the tangential acceleration. Alpha value we don't know yet, and we cannot decide whether it is going to be 0 or not. Otherwise there will be no acceleration for BC, which is not a very practical thing to have. So let us leave it here. We don't know the value of it, and let us try to plot this acceleration here. Okay, so from point B to reach point C, what we used to do in the previous cases, firstly we used to plot the centripetal acceleration, right, of C with respect to B. Then perpendicular to that, we used to plot the tangential acceleration of C with respect to B. And then we used to join these two lines to get the point C. But here what is going to happen? Here you can see that this vector here, in this question, this vector is not going to be present. This vector is 0. So what will happen? This point here, and this point here will coincide together. So this tangential acceleration of C with respect to A will be drawn from this point directly, since this value of acceleration is 0. So let us draw a line, that this line, tangential acceleration of C with respect to B, passing from B. So if we do that, this is the line that we will get, right? But tell me, whether should we make the arrow like this or like this? Do we know the direction of tangential acceleration of C with respect to B? Look, since the value of alpha is not known to you, alpha of CB you don't know whether it is in this direction or it is in that direction. So it is best not to try to put any arrow here. Just put a straight line, right? We don't know the direction. It is just the tangential acceleration of C with respect to B. And since centripetal acceleration of C with respect to B is 0, so this is the absolute total value of acceleration of C with respect to B. Right? Acceleration of C with respect to B. Net value is sum of centripetal acceleration, vector sum, and tangential one. Since centripetal is 0, so tangential value is itself equal to the total value. Okay. So this is the total acceleration of C with respect to B. Just like this case, just like the case of AB. There the tangential one was 0, so centripetal became the net value. Here centripetal is 0, so tangential has become the net value. But still in this line, we need to locate the point C, where the point C is going to be. On the basis of that only we can decide the direction and magnitude of this acceleration. So what can you do to locate the point C? Let us move to the last link, slider. We have used first link AB, second link BC, and now it is time for the last link, the slider. What do you think about the acceleration of slider? The acceleration of AB and BC, everything we have considered. But when we talk about slider, we can see that it can only move in a definite direction, right? It can either go up or it can go down. If we talk about its acceleration, then obviously its acceleration also can either exist in this direction or in this direction. Its acceleration cannot have any component other than the y-axis, since its velocity can only exist along this axis, right? Rate of change of velocity is acceleration. If it can move only along this direction, it can accelerate along this direction only. Acceleration can be here or here, but along the vertical line only acceleration is going to exist. So we can definitely say that if we are sitting on rest, or if we are sitting on A, because A is also a point of rest, then the slider can look accelerating to you in the vertical line, along the vertical line, whether up or down, that we don't know, that we are not claiming. But definitely if you are sitting on rest and you look at the slider, it will seem to you accelerating along the vertical line. Direction can change and depend upon what instant you are talking about. So from rest, if you look at slider, or from A, if you look at point C, its acceleration can exist along the vertical line only. So what we are going to do, we are going to pass a vertical line from A, because A is the point of rest, right? Zero acceleration. And from there we are going to pass a line which will intersect this existing line. Now, I have told this to you already, that it is not necessary that every intersection means something, right? There were such cases that we have seen in the velocity analysis where intersection was happening, but that was of no use. So we did not consider those intersections. But here, what do you think? This vector will include B and C. This vector is telling you the acceleration of C with A. Definitely it makes sense that this point should be C, because point C is missing on this line as well as on this line, right? This is acceleration of C with respect to A. So definitely this intersection point is C. You have completed the acceleration analysis diagram. Only one thing is missing: the direction of arrows. Quickly let us determine that. If you have practiced enough question, by now you would have put the arrow also, but let's cover it once more. The acceleration of C with respect to B is equal to acceleration of C minus acceleration of B, or acceleration of C can be written as acceleration of C with respect to A, and acceleration of B can be written as acceleration of B with respect to A. Why? Because A is at rest. And this can be rearranged, this statement can be rearranged as acceleration of C with respect to A is equal to acceleration of C with respect to B plus acceleration of B with respect to A. You just have to move it from right hand side to the left hand side, and this is what you will get. Means the vector sum of acceleration of CB and vector sum of acceleration of BA will give you acceleration CA. So this vector we have already shown here, this vector we have shown here. You just have to take their summation by taking them in the same order. Basics of mechanics, right? And then this vector will tell you the resultant. And it is very important in this question to pay attention to the direction of arrow, because the acceleration can be in this direction or in this direction, and both the options are present. Whatever answer you get, 2 omega square r or omega square r, both of them have their negative options as well. So you need to be careful about the arrows and the direction in this question. Getting it? So this is the acceleration diagram of this mechanism. Don't you think it is quite simple and easy? This much triangle we used to have only for a single link in the previous cases, and now for the entire mechanism it is just a triangle. Compare it with the previous acceleration diagrams. This diagram is pretty much easy, and you know the reason for it. I have told you the reason for it already, that if a full-fledged acceleration analysis question comes, it will require the use of proper scale and the tools and apparatus to measure angle. If you want to use it from graphical analysis method, it cannot be done. A full-fledged question cannot be solved like this. We have seen it in the previous cases. That is why whenever gate will ask you a proper full-fledged question, I am talking about a proper question, then it will simplify things for you. Look, gate simplified it, make it 0, it made it 0, simplified it, made it 0, right? But you must be ready for any question. I have told you the full-fledged method also. Now this question will look, and these types of questions which can be asked in gate will look very easy to you. So acceleration diagram is ready, and now is the time to solve the question. But before that, let me clear one thing to you. Making this acceleration diagram when you have practice, it will not take you more than 2 minutes. Within 2 minutes, you will be able to make it, even less than that, because I am explaining everything to you in detail. That is why generally when you will see that when I teach you or when I solve questions for you, it crosses 30 to 45 minutes when I solve it, because I am parallelly referring to different concepts that I have taught you already, right or not? But don't think that solving this question in gate using this method will take this much of time. If you know the concepts, if you have practice, within seconds you will be able to make it. Okay, now coming to this diagram, to find out this value, you need to know any other value so that you can use triangle property. Coming to the triangle also, since this vector is horizontal along x axis rather, and this vector is along y axis, this one, so obviously they are perpendicular to each other. It's a right triangle. And now is the time to use these values. These are also given to you in the question, which we have not used yet. Look, these are not the absolute length which are given to you. No unit has been mentioned about them. Look closely. Nowhere the unit of these things have been mentioned, because they are not absolute values. They are telling you the distance in unit. That this is 1 unit in length, this is 1 unit in length, and this is root 2 unit in length. Unit can be anything depending upon the question. But since this line is going along x and this is going along y, they are meeting, so it is a right triangle. A right triangle where base and perpendicular are of the same length. What does it tell you about these angles? 45 degree, right or not? And if BC makes 45 degree, if BC makes 45 degree with the x axis, or right now let us say horizontal, and with the vertical also, then you can easily know the angles here. This line here is moving perpendicular to BC, perpendicular to BC. And if BC makes an angle of 45 degree with the horizontal or x axis, so this angle also will be 45. This angle also will be 45, right? So this line also, just a second, this line also will make 45 degree with the x and y axis. So this angle will also be 45 degree, this angle will also be 45 degrees, correct? And now you have to decide this value. Think of any other values that you know. ACB, how much is that? BC multiplied by alpha CB. Alpha CB is not known to you, nothing is known about it. And what about this value? We know this value. It has been given to us, the values of R and omega. And don't think that, sir, it is centripetal acceleration, it is total. I have already told you, total one is centripetal for AB and total one is tangential for CB. So the value of total acceleration of AB is known to us, R omega square. So this value is known to us as R omega square. Now coming to this right triangle, tan 45 degree is equal to AC divided by AB, right? This divided by this. AC is equal to unknown acceleration of C with respect to A. Tan 45 is 1 divided by AB, which is R omega square. So what does it tell you? That acceleration of C with respect to A will be R omega square. But wait, is this the direction or only the magnitude? Does this value include the direction or only magnitude? What you did here, you used basic trigonometry. This is not the vector calculation, this is the trigonometric calculation, where you just considered this as a triangle and only considered these as lengths, not as vectors. So this value here is not present with the sign, it is just the magnitude. So you can say that this option and this option is incorrect because it is 2 omega square r. Now sign, you have to decide whether it is plus or minus. And in 2019 gate, students got confused in this, because those who did not know the proper approach got the wrong answer, and some of them also did the silly mistake. Look, that you can decide by the direction of this vector. What is the direction of this vector? Is it along y or opposite to y? Clearly along y. This is moving in this direction. Y is also moving in this direction. Question was asking you acceleration in y direction. It is along the y direction, not opposite. That is why its sign is also positive here. So option C is correct and option A is incorrect, right? So this is how you can solve this question using the vector approach of graphical analysis. Now, talking about this, is it the exact analysis or not? Some of you will say that, sir, you have not used the proper scales to draw these lengths. Or some of you will think that, sir, you used the software tools that you were having to draw the angles and all. But, sir, how will we be having those angles with us? Then I would like to refer to the discussion, 15-minute long discussion I did in velocity analysis regarding the graphical method, right? I told you that even if the graph is inaccurate, still you will be able to get the accurate answer, because whatever you are doing here is no way related to this graph. Even if this length of AC was this much, or this length of BC, I drew it like this, still you would write it as 45 and this as 45, because to conclude that these angles are 45, you did not use any graphical funda, you used these values which were given to you, right or not? That is why this answer here does not depend upon the accuracy of this diagram, right? But be very clear that in acceleration analysis, there can be many questions in graphical approach which you cannot solve without proper scale. Okay, so don't be having a wrong idea that whatever diagram we draw here can be used to solve the question. It will not happen for a full-fledged or any good question of acceleration analysis, as I have already told you. Now let us move ahead and solve another good question.